Hello YouTube! In the last video we talked about the SI units, the language of physics, and today we want to expand upon that idea by introducing the so-called prefixes. And let's start with the metric prefixes. Metric prefixes allow us to talk about giant numbers. Of course we could say, oh, that's 6,345,344 apples you got there. Or we could say that's 10 to the 24 kilograms you got there. Or sometimes we want to talk in different terms, and then we, for example, can say, oh, that's a yottameter there. Especially in daily use, we want to use these prefixes. For example, kilo, we never say that's like, oh, that's 1,000 grams. We just say, oh, that's 1 kilogram. We don't say, oh, that's like, oh, about 100th of a centimeter. We say, oh, that's a centimeter. We don't say, oh, that's about 10 to the minus 1 meter. We just say, that's a decimeter. Let us start at the top, though, where we have the yotta meter, or the yotta something. So yotta is 10 to the power 24, and as you can see, the steps are always 1000, or 10 to the power 3. So 1000 datagrams are 1 yottagram, and 1000 exagrams are 1 datagram, and so on. So we are going to skip in thousands, except for places I'm going to mark. Let's start with yotta. So we have 6,000 yottagrams are about the mass of the Earth, and if we have 73,500 zettagram, we have about the mass of the Moon. So that's quite a lot. About jumping, there is a special system where we don't jump in the 10 to the power 3 slots, in which we jump in 2 to the power of 10 slots. That's bits and bytes. If we talk about petabyte, for example, we don't really want to say that's 10 to the power 15 bytes, but we say that's 2 to the power 50 bytes. So divide that by 3 and multiply it by 10. So we have exabits, for example, about 64 quantum bits could theoretically result in a ginormous amount of bits in normal bits, 16 exabits to be more precise. Some scientists say that the human brain is about 2.5 petabyte, which is 10 to the power 15, and tera, 10 to the power of 12, is really common for hard drives to have like 2 terabytes or something similar to that. Just another short thing. A light year is about 9.5 petameters. So there you go. To have a whole gigasecond, that's 10 to the 9 seconds, is about 31.7 years. That's the median age in the USA of 1986. While a common megasecond, that's only 10 to the power 3. That's a common megasecond is only 11.57 days. So you see that 10 to the power 3 is gigantic, even though we never realize it. You have 11.57 days very often in your life, while 31.7 years is quite a lot. That's, you only have that about 2 times in your life, and you have the megaseconds about 2,000 times in your life. What other examples can we find for mega? We can, for example, find the megameter. 12.76 megameters are about the Earth's diameter. And kilo, we all know kilo. We all know the kilometer, we all know the kilogram, and those are very common units, so I haven't explained something. Hecto and deca are very rarely used, so I didn't explain them either. So then we go down to the negative powers, 10 to the negative 1, for example, and there we have deci. Decimeters, for example, 1 decimeter cubed is 1 liter. That's something you can remember, because it really helps us in combination with the next unit, that's centi. Centi and deci both are not 10 to the power 3, but 10 to the power of 1 apart. And centi literally means a hundredth. And when we talk about water, for example, we know that water has a kilogram per liter. So 1 liter water is about 1 kilogram. So we can translate that into kilograms per decimeter cubed, but that's not really commonly used. Commonly used are gram per centimeter cubed or kilogram per meter cubed. So if we want to have it in gram and centimeter cubed, we can just translate it directly, because that's kilo is 10 times 10 to the power of 3 times, sorry, and centi is 1/10, but cubed, so we have 1000. So we multiply it with 1000, we divide it through 1000. Or if we want to have it in kilograms per cube meter, we multiply the whole thing by 1000. So now, what other units do we have? We can go a bit lower. We can go to milli, for example. Having millimeters, that's 1/1000th of the meter. Now we resume with the 1000 steps. So now we go to micrometer, and everyone knows micro, for example, the microscope, apparatus to measure distances that are in micrometers, or to see things that are only micrometers tall or wide or high. Then we go down even lower and we get to nano, and nanometers are quite common. For example, when we are talking about light, orange light is about 600 nanometers, that's 10 to the power of -9. And we can go even lower. Picometers, or some of us know them, picometers are not as common as nanometers because they are so low. 10 to the power of -12, that's about gamma radiation. And 100th of an angstrom. An angstrom is 10 to the power of -10 meters, which is quite interesting, because often when we discuss atoms, we use angstrom, or when we discuss outer shells of atoms, to be more precise. I won't use angstrom too often though, because it's quite difficult to remember the unit for you, and I don't want to make it more difficult than it already is. So let's go down even lower. We have femto, and that's really small, 10 to the power of -15, and about 1.7 femtometers is the circumference of a proton. So that's quite low. Even lower we can go with the attometer. That's about an attometer is what the LIGO tries to detect gravitational waves with, and it seems that we have found some, but the statement is not as of this point is not yet verified. So let's go even lower. The septometers, 10 to the power of -21. About 310 septometers is the de Broglie wavelength for a proton accelerated in the LHC with about 4 tera-electron volts. We are going to talk about electron volts even more, so don't worry. Yocto is about the lowest unit, and that's even so low that we can hardly talk about anything. But we can go even lower. The Planck length is about the smallest we are ever going to talk about, and it's even smaller than Yocto. And that's even though Yocto is already lower than the de Broglie wavelength of a proton accelerated in the LHC. So that's quite tiny, and we can give even tinier with the 1.616 times 10 to the -11 yoctometers. That's the Planck length, so quite miniature. Let us look at other prefixes though. They're not really prefixes, but we are going to have to talk about them, which is time. Time is a little bit different. We talk about nanoseconds, we talk about microseconds, we talk about milliseconds, we talk about seconds, but we never talk about kiloseconds or gigaseconds or yoctoseconds, because when we get above 1 second we take another unit. So 1 second we multiply it by 60, we get 1 minute. By 60 we get 1 hour, and by 24 we get 1 day, and there's a number you can remember, or you can't if you don't want to. That's 68,400, which is from 1 second directly to 1 day. Why would you need such a number? Maybe because you remember the old definition of the second, which is just 1 over this number times a day, some synodic day of 1900. From day on, you can go directly to a year. That's about 365 days a year, except it's a leap year, then it's 1 day longer. And months have about 28 to 31 days in it, and there are about 12 months in a year. After a year, we go to higher units again, and then we talk about kilo years again, and yocto years, and such high year numbers. So after a year we start with a year again, and before a second we go with seconds. So that's quite a thing that we have to worry about when talking about times. So instead of just going with kiloseconds and so on, we have to skip from 1 second to 3.16 times 10 to the power of 7 seconds, with these strange units that don't really make sense. They are of course historically defined, and back then it all made sense, but nowadays they are not really metric and they don't really make much of sense. Still, they are what they are, and we today discussed the prefixes, the metric prefixes of the SI units, and they're up to yotta and down to yocto. We have discussed every single prefix we can add to a number to make it even higher or even lower. So now that we have learned to talk about high and low numbers, let's start to learn to talk about something else than just kilograms, meters or seconds, or our basic SI units, but let's combine them to get other units like meter per second. And that's what we are going to do in the next videos, and I hope I'm going to see you there once again. Goodbye.